Hi everyone. Thanks for joining us today for the Zeebe release webinar. My name's Daya and I'm the Content Marketing Manager here at Camunda. And there are two other beautiful people with me, as you can see in the picture here today. Daniel Meyer, VP of Engineering, and Jacob Swine, our co-founder and CEO of Camunda. So before I pass it on to them, I'm just going to go through some housekeeping items with you. So first and foremost, this webinar is recorded and we'll send you the recording tomorrow, so you'll have a chance to look at it in your own time. And we conduct these webinars so that we can answer your questions. So we really encourage you to ask us questions, and you can do that by clicking the question mark symbol on your screen and typing in your question, and we'll do our best to answer the questions at the end of the webinar. So with that, I'm going to go ahead and pass it on to Jacob.
All right, thanks, Daya. So, hi and welcome everyone from my side as well. So for those of you who don't know Camunda yet as a company, let me just quickly introduce ourselves. So we are a Berlin, Germany-based software vendor, and we specialize in business process automation. So this is what we focus on, and we create software for that, obviously. So we have a good number of customers, mostly mid to big-sized customers in many different countries all over the world. One important element for us is that they use our technology for automating their core business. So therefore, we are very developer-oriented in whatever we create, and we are obviously quite successful with that. So we can see that this is where we come from, and now looking at what we're introducing today is a completely new technology which is all about orchestrating microservices. So once again, of course, this is obviously about process automation, however, in a specific context. So we created this technology and we worked on that for quite some time now. We introduced it also, for example, in California, BPM Next, a couple of months ago. We received the Best in Show award there for this innovation, so there is already some credibility. However, today is the official launch, and I'm very excited to hear what Daniel has to say about what Zeebe is about and how it works and how you can benefit from it. Daniel.
Yeah, thank you, Jakob. Welcome also from my side. So yeah, today is a very exciting day. We are, after a lot of work that we've done on this project, we are today officially launching our new open source project that, as Jakob said, is called Zeebe. This project is very much a work in progress. I'm also going to go into that at the end of the webinar today. So we're launching it. It has a website. It's available at zeebe.io. You can all check it out. And also now we have opened the GitHub repositories that are all in the Zeebe-io GitHub organization, and there you can check out the source code and help us to improve it. Right, so what will we speak about today? I have compiled this outline of topics. First, we will look into how Zeebe simplifies microservice orchestration. I have some examples in there, and I will also do a demo. Then we'll look into architecture and internals. Zeebe is quite a novel workflow engine in the way it's built. It's very different from what we did in the past. It's completely re-architected from the ground up, and I wanted to take this opportunity to share a little bit some of the details on that. We will talk about performance, and then we will go into project status and roadmap. So what of all the nice things I talked about so far are actually there yet, and what isn't and is being developed right now, and then give you guys an outlook on what can be expected in the upcoming month. And we'll also look into the community, which channels have we created for you to get in touch with us, and how you can contribute to the ongoing efforts of building Zeebe. Then in the end, we should have ample time to go to your questions. So if you have questions, there is a question window in the webinar tool that you can use. You can type them, and then at the end of the webinar, we will talk about them, and I'll try together with Daya and Jakob to answer them as good as possible. So yeah, let's get started. Now, Jakob already said that Zeebe is primarily focused around microservice orchestration, and I wanted to just jump into it with a small example. This is also the example that most people use when they talk about microservices and long-running stuff, so let's do that as well. And let's think about, we are building a web shop where people can order their stuff, and they put it into a shopping cart, and at one point they say, yes, I really want to place this order. I'm pressing the last confirmation button. Now, we as a web shop, we now, of course, need to execute on that order, and that is a quite complex, that can be a quite complex process, lots of different systems involved, microservices these days, it can be long running. It is, of course, asynchronous, so the user should, of course, not wait in the web shop until the whole order has been executed. And if we are a web shop, then probably this is like our most critical process. If people order something, we should give it to them, and we should always give it to them and not only sometimes. And so this is, as we said, it's quite complex. And now, whenever these days we have complex systems, there is this trend in the industry towards microservice architecture. So as we start usually with new systems, we start small, and then we build in more features and more features and more features, and then it can get bigger. And at some point, we're stuck with this big monolithic system. And what people are doing now more and more is breaking this up into different microservices that then are distributed and usually communicate over the network. So I now have a distributed system. Now, this is nice, and also on the slide, it looks really nice. Okay, we have this big box, and now we have these smaller boxes. And when we look inside, then, of course, there is, again, quite some complexity because it needs to be somewhere. And I'm just going to focus on two challenges that we have when we deal with microservices in this context where we have asynchronous, long-running, complex, and mission-critical end-to-end processes that we need to do. And let's just make the example that now our team, we're a team in this organization, and we're tasked with building the order inbound service. So we have the web shop, new order comes in, we get called, maybe via REST API, and now we are responsible for delegating to more other microservices that implement certain aspects of the overall functionality. And this could be the payment service, I'm simplifying here, of course, a little bit, the inventory service, and the shipment service. And again, on this slide, it looks really straightforward. So, okay, we take in the order, and then we call them. Now, of course, there are certain challenges here, and I'm going to talk about two. The first one is, let's assume, yes, we do this naively. We call to the services, and then we do that. And then after, for a certain order, we have executed the payment. The fetch items call fails. Now we have a problem because we have already executed this payment, so we need to continue processing this order, but now our fetch items called failed, and how do we deal with that? And there's, of course, different kinds of solutions. You can introduce queuing, you can introduce reactive event-based systems. Again, based on queuing, you can do different things. When you look at what the companies are doing that are actually quite mature and advanced with microservice architecture, then a pattern suddenly forms, and that pattern is orchestration engines. So, for example, when we look into this is Uber, the taxi car company, and everybody knows them, and they have created a microservice orchestration engine. And when you look into their material, they talk exactly about this problem that I now try to outline. We're building a service ourselves in which we need to call out to different other services. It can be long running, it can be asynchronous, and we better make sure that we always do that. So they created one orchestration engine then that can do this. Then there is another challenge that we have to deal with once we do that, and that is, yes, we now have this distributed system, and here it can get harder and harder to really have visibility and proper monitoring into this distributed system and ensure working operations. So if I have this distributed system, it gets more and more challenges, the more complex it gets to answer questions like how many orders are currently being processed and where are they pending? What is the state of a particular order? Maybe I need to inspect this. Where do I go to see this? How can I fix up the payload of an order that is like pending somewhere and cannot continue because data is broken? Where can I go to fix this up and then restart this order and make sure it further processes its next steps? And again, there's this pattern. So when we look at another company that is quite mature around microservices, this is Netflix. Also they have created a project they call Conductor, and it's again a microservice orchestration engine that uses workflows. And what they say is that as the number of microservices grows and the complexity of the processes increases, getting visibility into these distributed workflows becomes difficult if you do not have this orchestrator that is this entity that can call out to different services in a sequence and keep track of where we are in that process. Also, when you look a little bit further, Amazon has created not one, but two of these things. The one has been around for quite some time. It's the simple workflow service, where again, they talk about the same problems and challenges that I now highlighted. And recently, they have created a new one, the step function service that they offer in AWS that also uses visual flows to let you orchestrate microservices. And we've been working on the Zeebe project now for almost a year, and we looked at these developments and we said, hey, we're coming from the BPM and workflow space and we have something to offer here. And our solution is the Zeebe. It's quite simple. What you do is you define your orchestration as a workflow using BPMN. This is what we bring to the table from our space. And then you can implement service invocations or business logic in your microservices using different programming language. And then you can give the orchestration to Zeebe, and then Zeebe can take care of the heavy lifting. And what it will do is it will walk through the process step by step, and when a certain task fails, it can retry it until it eventually succeeds, all along while keeping a complete audit log of everything that gets executed so that I can build tools to gain insight into the processes that I'm running. And right now I'm going to demo that. So I have prepared an orchestration demo that I want to show you and share with you. And I think as we do that, things get a little bit more clear. All right, so what we will start with is this. This is a workflow that I have modeled, an orchestration flow. I have used our Camunda modeler tool. It's open source. It's from our Camunda BPM project. It's currently not yet tailored down to Zeebe. So when you look here, you still have the Camunda BPM property panel, but I can already use it to model BPM and flows for Zeebe, and I have created a very simple flow here that's supposed to do the order orchestration. So we have a first task, collect money, then we have a second task, fetch items, and then we have a third task, ship parcel. And when we now look into the XML that is behind the scenes, we see that the service task has some new extension elements that are proprietary to Zeebe, and we see that the first task has a task definition, and it is of type process payment. And then the second task also has a task definition of type fetch items, and the third one is the ship parcel. And what we will do now is we will deploy this workflow into Zeebe. To do that, we first need to start it, and I'm going to take the opportunity to show you where you can get Zeebe. So this is the zeebe.io website that we have created, and you can go there and then you can click the install Zeebe button. This points you to the documentation, and then there's actually different ways of how you can download and install Zeebe. What I will show now is the simplest one, where you just download a distribution. For that, you are pointed to the GitHub release page. An alternative would be to use Docker. So here we can also run the Zeebe with Docker. It's on Docker Hub, and you can try it out by running this command. But since I now need to use my Windows environment for the presentation, I'm going to do the distribution. So this takes me to GitHub, and here we have our first release. And as you can see here, you have the artifacts, and what I did is I downloaded the zip file and I have extracted it. When you do that, you get a folder Zeebe broker with the current version, and in here we have the Zeebe broker. We have a configuration folder with the configuration file, and we have the bin folder with the executable that we can run. So I'm going to do that right now. And that's it. The Zeebe broker is there. And what we can see here is that it has bound itself to all my hosts here, and it has opened, it's now listening for connections on a certain port. And once we have done this, we can deploy our workflow that we've been looking into. And I'm going to do that using our command line tool that's called Zeebe CTL for Zeebe control. So it's Zeebe CTL. And this one needs a configuration file. So I'm going to say config. And I have a local configuration file that has the local host and port to connect to the Zeebe broker. And when I run this, then I actually get a help. And this gives me some instructions of what I can do here. And what we will do is deploy the workflow. And so we will say deploy. And then I point it to my resources folder here in my Java project. And here I have the orchestration flow. All right, so what we see here is that we have now deployed the BPMN file. It says deployment created, and this was successful. So that's the first step. It's now there. And I'm now going to my Eclipse workspace, and what I have prepared here is a very simple, like bare bones Java project. And when I go into this POM file, I see that like this is really simple. I need Java 8, won't work otherwise, and then I have a dependency to the Zeebe client. And the Zeebe client, you can think about it, this is a little jar file that I use in my application that I can use to connect to the broker, because both are decoupled and only communicate via the network. It's like when you use a database and then have a driver. So we have this, and then the first thing I'm going to do is I'm going to start my monitor. And this is a very simple Java application that uses the client. So we have a main method here. I didn't want to do anything fancy to keep it simple. And then I have the Zeebe client that gets created with the default properties. I connect to the cluster, and then I can select from my topics. Currently there's only the default built-in topic. And I now create a new event subscription. And the event subscription allows me to get notified whenever something happens on that topic in the broker. And what we say here is that we always want to start from the head, so the beginning of times, and then whenever a new event occurs in the broker. And what we're doing right here is simply printing it out to the console. So I'm going to start this. And here we go. We see that because we have started the broker before and deployed our BPMN file, that 3 events have already happened. And I can see them here. And it's not surprising that these are related to the deployment of our workflow. We see that there was a command, create deployment, that was getting processed, and then the deployment was created. If I would have had some syntax errors in my BPMN, then this would not have been successful, but this time it was. And then we see that we now have a new workflow also that has been created. We see the BPMN process ID. We see that it has version 1. Right, so now this workflow exists and we can start it. And I'm going to do that. For that, I have created another simple Java program. Again, the same thing, new client instance connecting to the broker. From the client, I select the workflows endpoint, and then on this default topic, I can now create a new instance. You pass the BPMN process ID. This is what we saw here. It's specified in the XML file. And then I pass in some payload. Here I have a little bit of example data. Payload in Zeebe is BPMN document. So every token that moves through the BPMN process carries on its back a JSON document that then the individual tasks in the workflow can get access to and then change the properties thereof. So I'm going to run this. All right, and this was successful, and since our monitor that has subscribed to the event stream is still there, we are getting updated. And what we see here is that a new workflow instance has been created. So I now have events of type workflow instance. Then the start event has occurred, the first sequence flow has been taken, and then we see the activity was getting ready, then activated, and then actually a task was created. And this task, this is now the actual work item that is being done by my workers that I can now start and that represent my microservices. So what we're going to do, I have implemented workers for these first two tasks. One is the fetch items task and the other is the collect money task. The fetch item task has been implemented in the Go programming language. The Go programming language is quite popular in as you know, in the microservices space, and this is a simple Go program that my colleague Sam here has written, and it's really simple. It's comparable to what we saw in Java. So here we are creating a new Zeebe client, and then what we do is we say Go open subscription. This spins off a Go routine, and then we pass in our parameters. And here we see the fetch items, which connects us to the second task in the workflow that we have deployed. And then up here we see the open subscription function as it has been implemented. And here we see that from the subscription channel, it selects messages, and as new messages come in, we then just complete them and print some logging to the command line again. So let's start this guy, and we do that with go run main.go. I need to authorize this apparently. So now it's there, and Sam has also implemented a very nice UI here. So currently inside this there is no worker running. I can say start. And now I have a first worker. I can say it again. And now if I go back to stats, then we see that currently we have two workers running inside this Go microservice. And so far no events have been processed because, yes, this is the second step in the process, and the instance I have started has only advanced to the first step, as we have seen in the event log. The first step is implemented in Java. So it's, again, very simple. This is the one. And again, we create a new client, we connect to the broker, we open a new, this time, task subscription to the default topic. We pass in our task type, process payment, how we want to identify ourselves as a worker, and then we say that we want to have 5 minutes to complete tasks that get logged for us. So now I'm going to start this. All right, and now some things have happened. First of all, let's go to the console output of this payment processor. We see that it has processed a first task. When we go to the command line where I started the Go client, also we see that one of the workers worked on the task. And when we go to our event stream, we should see that some things have been processed and completed. So before we got to the created event here, so the first task was created. Now that we opened the subscription from the Java worker, that task got log command, then got logged. Then it got to the client, there it was worked on, which was the system print line, and then it was completed. And then we see that the workflow instance continues after it. So the activity is now completing, the sequence flow is taken, and the next activity is getting ready, and then a new task gets created. This is the one that was completed now by the Go client. And after it, again, we continue to the next task. So this is how you can think about Zeebe, how it works. And then what we saw here is that everything is asynchronous. So we first deployed the workflow, and then we saw, okay, the workflow is there. Then we were able to start it. But at that point, none of our workers was actually running. So the broker just advanced to the first task and then waited for our first worker to come in and work on that task and complete it. And so forth. So this is very asynchronous and also very resilient. So something like a service connecting and disconnecting is just a non-event to the system. All right, so let's go back to our slides, and I now want to take the opportunity to show you a little bit about how this works internally and give you some context on that. what we have seen in the demo is that Zeebe is client-server. So we have the server, we call it the broker, because it doesn't really do much. It's basically distributing the work to the applications that then actually do the work. And this is why it's called a broker, so it's just mediating between these different applications. The broker can run as a cluster. So usually I would have more than one. They talk to each other, replicate data. I'm going to go a little bit into the details later. Then inside my application, I can embed the client. And then since this connects using the network, this client can now be written in different programming languages. And that enables me to also write my application in different programming languages. And so far, we have one implemented in Java, and we are working on the Golang client as well. And this is what we are initially focusing on. Zeebe, as I said, is a distributed system. I can start more than one broker. They start talking to each other, and they actually form kind of a peer-to-peer network. So every broker is the same. There's no special node that if it fails, everything goes away. So it's a peer-to-peer network. There's no single point of failure, and there's also no single choking point. Then I can scale this up and down, so I can start with 3 nodes and then start small, and then I can scale it up if I have more processing needs, and I can also scale it down again. We're trying to build this in a way that it works nicely with the container orchestration tools that are now getting more and more popular. Internally, we're working a lot with Kubernetes and also Docker and Docker Swarm, so that people can run this on top of container orchestration frameworks. Then Zeebe internally, it structures data into topics so that it can do its internal processing on top of that. And to do the internal processing, we do what most people call event sourcing. We also saw that a little bit in the demo that I did. So when I started a workflow instance, we saw that there was this command, create the workflow instance, then that got processed, and out of it came this event that said, okay, the workflow instance has now been created. And the data around that is organized into topics, and for scalabilities, these topics can be partitioned. And partitioning is kind of like sharding. It has the same value. And the partitions are log structured, which means that when I initially start a broker, there's nothing there, it's empty. And then as I do things, the events and commands related to the things I do get appended to this log. So at the beginning, we have the first entry. Each entry has a position in the log. The first entry has this virtual position 0, and then they increase as more things get appended. And what is really important here, that whenever we change data, it can only get appended in the end. So as the Zeebe also goes from one step to the next in the workflow, it won't go anywhere and change some data, but it will append these new facts that we have advanced from one step to the next. And for those of you who are familiar with the Apache Kafka system, this is where we took all of our inspiration from around this topic, and we are structuring it in a very, very similar way. Now for fault tolerance, these logs get replicated. So when I start a workflow instance as a client, I talk to the broker, and then I set my command. But before that command actually gets processed, it will be replicated to other brokers, so that we are sure that if we lose one of the brokers, there is more copies of the data on other nodes. And then this distribution looks like this. This is again exactly like you would also have it in Kafka. I have my brokers, and then here we have an example where we have one topic with 3 partitions and replication factor 3. So of every partition, I have 3 copies. And then this broker is then the leader for the first partition. This means that all the write and read requests go to this node, but as it changes data, it will replicate it to these 2 other nodes because they are follow-up for that partition. For the second partition, it is different. There, this broker here, the second broker, is leader, and then will accept all the requests and do all the processing and then replicate data to the other brokers. And for partition 3, the same, again, another broker here is the leader, and the 2 other ones are follower. This slide I created to give you a little bit more details on how you can imagine this to work internally. What we have here on the left-hand side is the client, and in the middle we have the broker. Zooming in a little bit, this is the partition leader for the partition we're currently interacting with, and then we have two other brokers on the right-hand side who are followers for that partition. And now I make the example of the data flow when the client completes the task. And so what it will do is it will send a complete command to the partition leader. Before anything happens with that command, it will first get appended into the log, so that we have a record of that this client wanted to complete this task. Before we then actually process it, we will first replicate it to the followers so that we have more records of that data item. In the event of a failure, we can fail over to these other nodes. Once data has been committed, commit happens when more than the majority, like if the majority of the, we have quorum, if the majority of the brokers who have this partition have a copy of the data, then we can actually start processing it. And for this, we have our stream processing model that happens on the broker itself. So the stream processor walks through this log one entry at a time, and when it gets to a new command, then it will read it, decode it, and then it maintains internal state for every task. What is the current state? Is it open? Is it locked? Is it completed? What is the state? And then against that, so this forms a state machine, and against that we can then validate the command and then make a decision to decide whether this command is valid or not. If it is valid, we apply it to the state, and then we send the complete response to the client. So this level, it's very, very simple. If what I said before, if we fail, then we maybe lose this state in the stream processor, but we can replay and reconstruct that from the log that we have replicated to our followers. What that also means is that Zeebe does not need any external services. So when you run Zeebe, you only need this broker. It will store data locally inside the file system on that machine. And then if you want to have fault tolerance, you can start multiple machines, and then it will replicate to the file system on those other machines. So that means that with Zeebe, you don't need any additional database or message queuing system or other things like caching or search indexes. You only need this broker and a lot of disk space on the machine that runs it. Now to look a little bit into the topic of how the communication with the microservices works. So the broker is supposed to distribute the work to the microservices, and it does that using the publish-subscribe protocol that we have implemented. So the broker is started, and then I deploy my microservice that can contain the client. And then the client will subscribe to a particular task type on the broker. This is what we have seen in the Go code and also in the Java code. And then this is a TCP connection that is open all the time. And then when something happens on the broker, like the task is getting created and is now in a state where it can be logged, then it will get pushed to the microservice, so that to keep latency in check, it gets pushed from the broker to the client, and then we can work on it and then complete it. And this protocol is very efficient. It's non-blocking in both ways. There's a lot of pipelining happening. And it also embeds the back pressure protocol to make sure that since the broker pushes out the tasks to the clients, we need to make sure that the broker does not overwhelm the clients with too many tasks. So that works in a way where the client will send credits to the broker, and that means, hey broker, I can complete like 100 tasks, and when that credit is used up, I cannot complete more tasks. And this allows the client to control the rate at which tasks get assigned to him, and by that throttle based on resources and how long the processing time takes. Again, here the inspiration is, of course, again coming from messaging systems. Now, I can use this in two scenarios, and the left one is what I did in my demo that I did. So here the services directly embed the client, and then they can directly subscribe to the broker. I can do this when I go all in with Zeebe and I say, okay, I'm building new services. I want them to be orchestrating it with the Zeebe broker, and now I'm embedding the client into these services. That's scenario one. This is, of course, the most efficient, but it's maybe not the most easy thing to do to get started. And if you want to get started and have existing services that already expose the REST API, then what you can do is you can build this orchestration service, and in that you subscribe to all the tasks in the broker, and then you can make the REST calls to the services, and then you get all the benefits around visibility and retries. So if you call a service and it fails, then you can signal failure to the broker, you get retried, and you get all of that fault tolerance and making sure that eventually all the workflows get executed. You get all of those benefits and also the complete event log and visibility into everything that happens. Right. Now, in terms of performance, we are building Zeebe in a way that it can do a lot of throughput on a single node, and then you can scale it beyond the single node to have the scalability and fault tolerance across nodes. And to achieve that, we follow certain design principles. It's doing a lot of I/O. It's actually not doing a lot more than that. So what it needs to do, it needs to read data from network that comes in, a request from the client or the replication, and then it writes to file system. And to do that efficiently, we are batching a lot to amortize the overhead costs that are related to that. Always, whenever I do an I/O operation, it's quite costly, and if we do a lot of data at the same time, batching that, then we can amortize on that. Also, the fact that we're doing this stream processing on top of the log structures that are files that live on file system gives us really nice linear read and write data access patterns. So we append always to the log, which is a linear read, linear write, sorry, making the file larger and larger. And when we process, we just read sequentially through the file, which is the most efficient data access pattern that I can have. We are investing a lot of time into building very optimized and cache-efficient data structures that are compact. For example, to store the state of the state machines we have inside a broker, recording the state of every task. We have a very efficient map that minimizes cache misses as you go from the key to the values. And then we are using some interesting log-free algorithms and concurrency models inside the broker to make sure that we use threads as efficiently as possible. And the broker is also supposed to be garbage-free in the hot path or in the data path, so that when many requests come in, we make sure that not for each of those requests we create Java objects on the heap that then need to get garbage collected, but we actually doing this in more efficient ways where we cycle buffers and use the same memory all over again to make sure that at least in the data path where data is supposed to flow through the system, we don't allocate for every message that comes in. Now the results are that when I use this on modern hardware with modern SSDs, gigabit Ethernet, then I can process 160,000 to 200 events per second. Now, as we saw, of course, is that one workflow instance is many events, so you have to break that down, of course. Currently, if you try out the release, we have some performance regression that came up shortly before we did the release, but we didn't want to block the launch of the project, so you're not getting to those levels right now, but we have our end of the month, end of August release where we plan on improving the performance so that we can get to those numbers again. All right, then project status and roadmap. So where are we? Now Zeebe is currently in a development state that we call tech preview. So we want to now share this project with you. Today is the launch of the open source project, but that doesn't mean that Zeebe is now finished. So many things that I was talking about now on the slides are little bit future work, and I have a next slide where I can show you what is already there and what still needs to be developed. So the initial scope of the system has not been completed yet, but we still want to launch this open source project today so that we can start getting your feedback and your input. And if you are very enthusiastic about this project, then you can already start using it experimentally and again help contribute, help building it, and giving us feedback. And also, I just want to say this explicitly, this is not production ready. You should not deploy this and rely on it to work reliably at the moment. What is there? Currently, you can have a single topic with a single partition that is built in. Already, you can have the failover and replication across different nodes. You can have task subscriptions for the workers and event subscriptions for the event stream. And on the level of BPM and workflows, you can have sequences of tasks. There are no gateways yet, so you cannot have parallelism yet. And we have data mappings between tasks. I said that every token that moves through the workflows carries this JSON document that gets carried over from one task to the other. And if you want to build reusable task handlers, then you can actually map data from this document into the tasks and back. And we also have an incident concept where if an execution gets an error, for example, by invoking a task handler 3 times and still not having success in completing the task, then we will not redo that, retry that forever, and then we go into an incident. You can subscribe to them again, and then there is APIs for incrementing retries again, things like that. Now, what is our roadmap? We have 2 milestones that we want to reach. The first one is to achieve the scalability that I was talking about through the partitioning, making sure you can have more than one partition. And for that, you will be able to define topics with multiple partitions and replication factors, then deploy workflows in a way that they get assigned to multiple partitions, and then have the partition-aware subscriptions so that when I have a single subscriber to a topic that has multiple partitions, that subscriber actually sees all the data that is in all the different partitions. Then we, as a next BPMN feature, we also want to build the exclusive gateway and the conditions so that in the orchestration flow you can take different paths based on data and conditions. Once we are done with that, then we will do a next milestone, and this one is focused around achieving production readiness, so to make the broker more resilient. Currently, as I said, it's very experimental, very early stage, so you will run into many problems and bugs when you now use it. And then we will do a milestone where we try to bring that to a stage where it's production ready so that you can use it in your projects reliably. Now, in terms of the community, as we say, Zeebe is still early stage. We're now launching this open source project for the first time, but there's already different ways how you can contribute. You can, first of all, try out Zeebe and provide us feedback in the forums. We have set up a forum at forum.zeebe.io. And also you can start contributing to Zeebe. So for example, since we are now just starting, there's a lot of things to do that bring this more into different communities. So for example, in the Java framework integration, you could do Spring integration, Spring Boot integration. What would be really interesting to explore is integration with the reactive streams stuff that is coming up, because we have a lot of reactive elements in these subscription-based protocols. We can write the clients in different languages. For that, the Go client is quite strategic for us because the Go exposes the, I think it's called native function interface. So from different script languages, you can wrap the Go client and bind to it, just like you could do with C. And then we can write idiomatic JavaScript clients based on the Go client. To then, for example, implement services in Node.js, things like that. There's a lot of documentation that needs to be written, and we're also looking for people who are interested in maintaining Debian package or other Linux packages so that Linux users can install Zeebe with their regular package managers. Right. then yeah, we're basically at the end of what we have prepared for today, and what would now be interested in is answering some of your questions. So I see that Jakob has been looking into them. Jakob, have we received some questions that we can maybe answer?
Yes, we did indeed. So thanks, Daniel, so far. Okay, there's questions coming in right now while I'm looking at the list. So one that just came in is what are the main benefits of Zeebe versus Netflix Conductor and or Uber Cadence? Yeah. So why should I look at Zeebe if that's still already there? You know?
Yeah. So well, as I said, Zeebe is currently very early stage. So currently, you would not. But I can talk about the vision for the future that I also presented today. And there's things that are different. First of all, we bring BPMN to the table, which gives you the visual workflows and all the benefits around that for being able to communicate around these flows graphically, etc. So that is very interesting. The second thing is that this system is very event-oriented, so you can subscribe to these events, and then you see the progress that is happening in the system. You can easily integrate that with systems like Elasticsearch or other monitoring systems. You can build a custom business activity monitoring on top of that, so you could also bring it integrated with Kafka and then have all your events there. That's certainly very interesting, this event-oriented nature of it. Then it's once we will be finished, it will be very easy to use because it will not actually rely on any external services. So you don't need any additional databases, you don't need any additional things to run it, and that is quite attractive for these other engines that we have mentioned. You need things like Cassandra or Elasticsearch to run them, and with Zeebe you just need to understand Zeebe and run it. So that's going to be a huge benefit, I think. And then also when you go into scenarios where you need the very efficient and high throughput things that we're building with our very optimized subscriptions. So the way the client integrates with the broker in Zeebe is unique across these systems because we are doing these publish subscribe protocols. This is very efficient. If you look at what the alternatives are doing, it's usually a form of long polling where the client polls the brokers, and then you need to scale that polling infrastructure. While here you have this very efficient protocol where you just subscribe, and then as tasks get available at the broker, it can just push them out, and then you get notified, and this is highly efficient.
All right, thanks. Maybe just a follow-up question that is also related to that. So I think you mentioned that, but just making sure that it's clear. So does this mean that I don't need any database for Zeebe? I mean, where's the data being stored? Is it like without any database or anything?
Yeah, I can, yes, so the answer is yes, and this is also what we did here. So when I did the demo, as you saw, I started a broker, and then in the configuration here, it says that the directory for the data is data, and then we have this directory right here, and this is a list of folders and file systems where we're storing our stuff, and the most important thing is the logs. We have a default topic with the first partition 0, and in here we have files. Since I did not do a lot of things, I have only a first segment in that partition. You see that it has 30 kilobytes of data, and when we open this with a text editor, the file is binary, but this is where all my data is. So we see that yes, somehow the BPMN is in there. We have some binary things happening here. Again, the BPMN, and then this is actually all the data related to what we actually did. So we see that there was some subscriptions being opened, and this is the event stream that we also saw being printed out by the Java program that I had written here. And this is the file that gets replicated across machines when I run Zeebe as a cluster. And then this file will live on multiple machines so that when I lose one of my brokers, I have copies on other machines. And then I don't need another database for it because it can do all of that on its own. So this is, of course, very different. So if you have been using traditional workflow engines in the past, then they always relied on databases. And now we are at a point where we have a very optimized persistence that doesn't need a database. And you've seen the same evolution in the messaging space. So when I think about like 10 years back, how messaging systems work, they were most of the time based on relational database to implement their transactions. And then at some point, messaging systems took this evolutionary step where they started to do persistence themselves based on, again, journal files. And then that was also accompanied by a leap in performance and throughput in messaging. And what we are doing here is the same, but for workflow.
All right, thank you. So one of the questions that came in quite early was, exactly. How do you get audit trail functionality into the Zeebe orchestration? Any answers?
Yes, so the audit trail is exactly this, right? So this log of events that we see here, this is the complete audit trail that has happened. So what I see is that as we walked through it a little bit, so all the steps that have been executed along with with some details, like, for example, context, what workflow was this, which activity was that, the payload. So I get everything. And then with this, I can do different interesting things. I could do event processing on top of it. I can build something that, if you are familiar with traditional workflow engines like monitoring tools, so I can put all of this into a search index like Elasticsearch and then start materializing some views that I can query, like, for example, with a particular for a particular workflow instance, where are we currently pending? The workflow instances, you can see them here. They're called workflow instance key. So with this data, I can do interesting things, and it's all there, and it's log structured, and it's in the form of this event stream that has a clear beginning and a clear end. Also, I can process it multiple times. So if I stop this and then start to monitor again, then I can see that, yes, I'm getting notified about the same events.
All right, thanks. Another question that came up right after you ended the presentation was, when will it be stable for production?
We're doing the best we can. We're currently targeting the end of the year. That would mean that starting January, it should be possible to run it in production. As always with software projects, things get delayed, but that is our current plan.
Thanks, Daniel. And since we have a culture of under-promise and over-deliver, I'm optimistic. But we will see, of course, right? All right. Well, there's lots of stuff here, really. So someone's asking, what was the reason for choosing to build your own replicated log? Question mark. Inspired by, in quotation marks, versus using Kafka?
Yeah, well, there's different reasons. It was obviously something that we discussed in the beginning. And the most important reasons are, first of all, we wanted people to operate and run this without first having to run Kafka initially. Because, I mean, running Kafka, it's already, you need to operate Zookeeper, then you have to operate Kafka, and then you could operate Zeebe. And we wanted to take the shortcut and give people something that is easy to operate and that they can just run out of the box and doesn't need an external distributed system to build on top of. That's one reason. Another reason is that since we're doing all of this stream processing on the broker, this gets extremely efficient if we actually do that if we have the data on the same machine that then also does the processing, because then we can just process on top of the file system, and then this is very efficient and really fast. So the main reasons were performance, maximizing on that, and then also making it easy to operate so people don't need to first run Kafka and then they can run Zeebe. So these were the most important reasons.
All right. Someone's asking, will Zeebe come with something similar to the Camunda cockpit that can be used to view the audit logs and monitor progress of process instances?
In the future, maybe yes. So at the moment, we're focusing on the orchestration engine itself. So we're doing this persistence, we're doing this replication, we're doing the things that we need to do to get this stable and build out the initial feature set. Once we are done with that, we can look into, okay, what are the next steps? That can be building more BPMN features like message correlation, timers, things like that. It can also be building a monitoring application, as we have seen this user is probably familiar with Camunda BPM, so as we have seen in our other products. Currently, we have no, let's say we have plans to do that, but no concrete plans in a sense that we would know when we will start with this.
Yeah, maybe just to add my 2 cents from that side. So we focus now on the core technology, which is obviously about execution, and we're working towards production stability, looking at the end of the year. And hand in hand with that, of course, goes the need for monitoring. So we will certainly sooner or later release something for that. However, at the end of the day, it also depends on what you actually need. So, and this means that you who are attending this webinar are also, you know, in the driver's seat to a certain extent, that you can use the technology, try it out, and if you say, hey, I want to use this in production now, and I will need some monitoring app for that, let us know, because this will help us setting priorities. So it's always, you know, it's always a joint venture to a certain extent. Right. So another question is, yeah, I mean, this has come up a number of times, so I think it makes sense to tackle that. Just as one representative for that, will you be replacing Camunda runtime with Zeebe? So what's the relation between those two technologies, really?
No, so Zeebe is focused on microservice orchestration in, let's say, cloud-like environments where you need replication and where you maybe also need this throughput and the scalability that it promises to offer. But going with that, it is a very narrow and focused technology at the moment, so it doesn't have a lot of features, and it will probably not have a lot of features for the foreseeable futures, because we want to really focus on this microservice orchestration use case. Camunda BPM is a very mature product around workflow and business process automation and business process management. So there we have many features around business process management that are for the moment out of scope for Zeebe. Things like DMN, things like CMMN, things like very sophisticated APIs around operations and things like that. So here in Zeebe, we are now very small, very focused on this use case. So if you have the very specific requirements that Zeebe is currently targeting, then it would be really nice to have a conversation. But if you are generally interested in doing business process automation and workflow, then you should very much go with the Camunda BPM project. We are continuing to develop Camunda BPM. The 7.8 release will come out in November. It will have many new features. It's one of the biggest releases that we have ever done. And we are very committed to developing it further, and there is many things coming up there. So Zeebe is not meant like, okay, replacing the engine inside Camunda BPM. That is not our goal around that.
Yeah, thanks for explaining that. And of course, the question is as well about the answers, exactly as you said. So we're simply bringing the concept of workflow and workflow automation to, let's say, a broader round of use cases. That's the attention here. Someone's asking, can Zeebe work with any serverless tag, in brackets, like AWS Lambda? Question mark.
So not out of the box, you would need to integrate that, but the way Zeebe works with everything is asynchronous, the decoupling, the tasks get queued if no worker is currently subscribed to it. All these principles and patterns are a very, very good match to the ideas around lambdas, for example. And what would be really interesting is writing a very small integration layer where I write maybe in Java or Go a glue layer between the task subscriptions in Zeebe and then invoking Lambda functions in AWS. And this is something I wanted to look into actually personally for quite some time now, looking at What are the integration points that we can have with Lambda? The obvious simple thing would of course be to bridge between the Zeebe task handler and, I don't know, REST call that you do against Lambda or something like that. But maybe you can even write like a custom plugin to Lambda that then subscribes to Zeebe and kicks off the Lambdas. But again, this is something that would be also really interesting if somebody wants to explore that, to have an example in our GitHub space, a simple project that provides a task handler that integrates with Lambda, and whenever a task gets created in Zeebe, the Lambda gets invoked. That would be really, really cool.
Right. So there's one last question, and I think yeah, it's someone who has already asked about, how does it work that my services are found by the engine, and now asking again, please show me the service task configuration. So, and this seems to be a hands-on question. Maybe we can just quickly recap how this works, and then we're done for today. Since
Yeah. So let's start with the BPMN and the collect money task. And when I go to XML, we see here that we have this line here, the Zeebe task definition that defines this as being of type process payment. So here I can just put some string that I can come up with. It could be something else that identifies my task. And this is the task type. Now, when the Zeebe broker enters this task, then the task gets created. And when I then implement my task subscriptions, this was my payment processor here, then I can see here that I'm using this same identifier here as the task type in my subscription. And this is the thing that connects the two, right? When I create a subscription with this task type, the broker knows that this one here is now interested in tasks of type process payment. And then we open a subscription, which is the TCP IP connection between the client and the broker. And then when a task of that type gets available, we are notified, and then we can process it. So the only thing that connects them, it's very simple, is this this simple string here that I can define. That's that. Then if you need to do data mapping, we have some documentation around that that you can find. So documentation is obviously at the moment also like a lot of work in progress, but here we have some documentation on how you can have more extensions here. So for example, here we have an IO mapping in addition that using JSON path, which is like XPath if you are familiar with that, but for JSON, we haven't invented it, it exists. And then you can like use the dot notation to say, okay, my JSON object, the dollar identifies the root, dot property, dot another property, and then you can copy data from the document in the workflow to the document that then gets passed to the worker. And this is how you can manipulate the payload. And we have documentation here around these mappings. So I hope that answers the question. If not, yes, we are there in the forum. You can bring up questions there. We will also organize a chat where you can talk to us even more directly, but we will focus that around if you want to contribute. So if you have user questions, ask us in the forum, and then we'll have a chat where you can talk to us if you want to contribute, write a client in another language, want to do this Lambda integration that we've been talking about. Yeah, things like that.
Thanks, Daniel. And that's also what I would like to emphasize. So it's great. It's a great amount of interest here. So too many questions for us to cover. Sorry about that. So for any questions that are unanswered, please simply go to zeebe.io. That's the link. Visit the forum. Ask a question over there. You will get an answer in no time. So the guys are super keen to help you getting started with the Zeebe. So therefore, please use the forum. And thanks a lot for your interest and your time. And thanks a lot to Daniel and Daya. The very last question I always get is, what about this webinar recording slides? Will we get that? I think you said that, but maybe you can just recap, Daya.
Yeah, sure, Jacob. Before I do that, I also would just like to draw attention to our newsletter. Daniel, if you could quickly just show people where they can if you go to zeebe.io and scroll to the bottom of the page, you can put in your email address if you want to stay up to date on any extra releases or information. And you can also follow us on Twitter at ZeebeHQ. But yes, as Jacob mentioned, we'll be sending you this webinar recording so you can watch it back in your own time tomorrow. We'll be sending that via email, and we'll also send you the slides of the webinar as well in that email. So you'll have the time to look at it again. So with that being said, thank you so much for joining us today. Thanks for all your questions. And yeah, we look forward to you guys using Zeebe and connecting with us in the community forums. Have a great day.
Thank you. Bye.